right, so good afternoon. How's everyone doing? Great, okay, good stuff, excellent. So, I know that I am in between you and lunch. So, yeah, they told me to rush, so this is going to take about an hour and a half, so no, I'm kidding. Okay, so before I start, quick question. Who has heard about this paradigm? Fresh body, fit mind. Some of you. Okay, so this paradigm basically states that in order for your brain to get enough blood and oxygen, you're supposed to exercise, okay? So you have to have like a fresh body. So in light of this, I would like everyone to stand up. We're going to do an exercise together. You've been sitting here for hours now, so it's going to be a very, very simple exercise, okay? So the exercise, I'm going to show you my back, so I do apologize for that. So it's going to be a very simple one. All you need to do is raise up your arms so that your elbow is level with your eyes. Yeah, okay? Open up your palms. Yeah. And now clap. Okay, thank you. So what happens, I take these pictures, go back to my boss, and I get the bonus. Anyway, so thank you for that. So on a more serious note, so today we're going to talk about web performance, and there were some talks, and there will be some talks that touch upon web performance. And of course, in today's ecosystem and environment, there's no denying in the fact that web performance is in fact very, very important. Now, there are lots of case studies and use cases that show that, a change of X yielded in an improvement of Y. I'm not going to bore you with that. There's lots of stuff that you can find on Google. But what you need to understand is that web performance is not a thing that you do once, okay? It has to be an iterative, continuous thing that you do and that you perform in your application. So you need to measure the performance of your application, you need to understand what those numbers mean, and then you can act on them, right? And you have to keep on doing this all over again. And I really, really like this tweet from Eddie Osmani, and if you don't follow him, please do. He has some very good tweets and insights into the various aspects of web performance. And he said, if you want a fast site, test on slow hardware regularly. And I think this is true because sometimes as developers, we're just used to having the latest MacBook with an M2 chip and an iPhone or a very high-end Samsung device. That's not realistic. That's not going to be the user base that you're targeting when it comes to your application, okay? So try to test on slow hardware and try to do your tests regularly. Now, before I get to the specifics of the Angular side of things, I also want to mention the tools that you can use to measure web performance. And often when I do these workshops or talks on web performance, I always point out the fact that what you need to measure is the so-called RUM data, which is real user metric data. So running a Lighthouse test in your browser is a very, very good start, but it's not representative of how your real users are experiencing the performance of the site. Okay, so there are various tools that you can actually show you how those users see your site. So those would be Chrome User Experience Report, Debug Bear, PageSpeed Insights, and many, many others. So you can take a picture of this and then just look into these tools. Now, from the Angular side of things, I'm going to be talking about two sort of tools that are available. There are many others, but these are the two that I'm going to be focusing as part of my talk. And one is going to be the Source Map Explorer. And then, of course, if you are not using the Angular DevTools extension, which is a Chrome extension, then please do that. Specifically, if you want to see how your site or how your Angular application performs, then you should use the Profiler tab, which I'm going to have a few screenshots about. So as part of this talk, we're going to talk about these four things: out-of-bounds change detection, zone pollution, how to manage the final bundle size, so the final JavaScript/Angular bundle size, and of course, we're going to also talk about a little bit about media assets. So let's start with out-of-bounds change detection. So out-of-bounds change detection happens when you make a change in a component and then other instances of this component also trigger change detection. And that should not be the case. Okay, so there are a number of things that you can do, and of course the most straightforward one is to use the on-push change detection strategy. So let me walk you through an example, right? So let's assume that we have an app component which then basically uses another component, but it uses it twice with different sets of data, okay? And so when it comes to actually measuring what's happening on this site, we see the airport list. We try to add something to that list. You can see I've typed something in, and I also have on the right-hand side the Angular Chrome extensions profiler tab open, and you can see that every time I type a key, it's going to detect changes in both instances of that component. And that shouldn't be the case, right? Because I'm only sort of working with just one. So how do you get rid of this problem, and what are the other things that you can do in a situation like this when you're displaying a large set of data? So the very first thing that you can think about is how do you break up that larger component into two separate pieces, okay? So as opposed to having one component with an input box and a display list, you could create a separate input component and then a separate component to display your data. Then you can change the change detection strategy to on-push on the input component, which means that it will only trigger the change detection when you pass a new value to that component. Then, as sort of extra two things, you can also use immutables.js immutable list, because that will prevent the mutation of your array references. So as opposed to just using an array of objects to display the data, you can use the immutable list. And as a sort of other extra thing that you can do, you can look into using the virtual scroll viewport, with which you can just make sure that a smaller subset of the data gets loaded initially in your Angular application, and as you scroll, the additional data will load, as opposed to loading everything when the page loads. Okay, so this is how it would look like after that. So still you have the app component, and then instead of just the two airport components, you now have two input components and then two list components with the on-push change detection strategy. So in terms of code, and this is just very small code snippets that I have here. So you import list from immutable.js, you then change your input data to take that list as opposed to just a standard array, and then in the middle you see the change detection strategy, so you can change that to .onPush, and that is now going to apply the onPush change detection strategy in the component where you have enabled that line of code. Okay, and then after doing this update, the very same example, you can see that the, probably you can't see that, but the time from 3.7 milliseconds for the change detection went down to 1.2 milliseconds. So basically we halved that just by applying these changes. Then we have zone pollution, right? So zone pollution happens especially when you try to bring in a third-party JavaScript library that uses things like set timeouts or even triggers. So what happens is that these events in the third-party JavaScript library will essentially trigger the change detection cycle inside Angular. And that's not something that you should do. So how do you avoid that? So in my example, I have created a tooltip directive using a third-party JavaScript library called tp.js. Okay, and all I do here is just make sure that I display an image of an airport when someone hovers over a piece of text. And I then edit this directive into that other table. And so what happens every time when I hover my mouse over the airport name, I get that tooltip with that airport picture. Now this is an oversimplistic example. Think about, maybe that every time when you hover your mouse over that the text, a different image would load. Okay, I just didn't want to share all that code here. But if you look at the profiler, because I'm running a profiler session while I was doing the onHover, you can see every time when I display that tooltip, there's a change detection happening. It shouldn't, right? Because it has nothing to do with Angular. And so what you do, or what you can do, is call this run outside Angular method, which is basically going to exclude that piece of code from Angular's zone. And so just by doing this change in that directive, in the directive's code, Redoing the same example doesn't even record anything. There's no change detection happening because now you're running that code outside of Angular's world, okay? And that, of course, is also going to help with how performant your application is. You're not going to end up having these change detection, unnecessary change detection cycles. Then we also have a rather large topic, which is managing the final bundle size. And there are many aspects for this. So the tool that I like to use to sort of analyze and see what the final bundle contains is by calling the Source Map Explorer. You can install that using npm. And all what happens is you generate your final bundle, but you need to generate it using source maps, okay? Because if you don't add that flag, then the Source Map Explorer is effectively not going to have a source map to explore, right? That kind of makes sense. So you build your production configuration with the source map flag. Alternatively, you can also go into your angular.json file, go into the production configuration, and then you can specify what the source map should contain. So you can add the hidden script styles and vendors to be all true, and some of those are by default set to false. So if you set everything to true, the final bundle and the source map will contain all the JavaScript that you have. And when you run this tool, this is what you're going to get. So even without you seeing what's here, you can see that there is something that takes up a lot of space. And what you need to remember is that the output that you see here is relative. So the bigger the space something takes, the heavier resource it is going to be. And in our case, I'm just going to zoom in on the sort of head section of this result. What you get is a breakdown of all the dependencies and all the files that make up your bundle, and you get a percentage for them, okay? So in this case, out of the 648 kilobytes of the overall bundle, about half of it is moment.js, okay? And there's, you can basically click around and dig deeper into these various aspects of this. So how do you manage the final bundle size? Like, what are the things that you can do to make sure that your final bundle, your final JavaScript bundle is going to be smaller? So you can, make sure that you remove unused dependencies. So I had this every now and then where I added maybe an HTTP module in my Angular app. I tested something and I forgot to remove it. And I looked at the Source Map Explorer and there was, 15% of the HTTP module of the overall bundle. And I was like, okay, I don't need that, so I can remove that. Also, think about if there is something that you can actually recreate using vanilla JavaScript or TypeScript. Often, we have the tendency to rely on third-party libraries and scripts, and we install this and that and other things, whereas you need to think critically, and you need to think, do I actually need everything that that package is bringing? And then, of course, try to use modular imports to allow tree shaking. So one example is, Moment.js, and I don't have anything against it, is a very good library, it's very popular, and let's say you want to print out a date and format it using this format. So we bring in moment.js, we call moment format, and then the format string, okay? This will, as we saw, is going to contribute to about 50% of your overall bundle. The same piece of code can be easily rewritten just by vanilla JavaScript, okay? Using the datetime format method. It's a little bit longer and a little bit more complex, but ultimately, it results in exactly the same thing. And now you have removed an entire dependency from your project because you just don't need it anymore. And of course, I think it goes without saying, this is a fairly common thing to do. So don't try to import everything in your files. If you don't need it, try to be very selective, okay? Now, there are some third-party libraries that do not allow you to be very selective about your import. So then again, try to think whether you should install something else, whether you can actually get rid of the dependency, et cetera, et cetera, et cetera. And then last but not least, there's also the fact, this is kind of relevant to the final bundle size, but this is more about lazy loading things in Angular. So in Angular, you can create the so-called feature modules. So what you see here is just a code snippet about from an application with a root definition. So if you don't do lazy loading and you don't use featured modules, what happens is that you're going to end up having one single JavaScript file, which will, in our case, main.js, which will contain all the code for your Angular project, okay? But it's a much better strategy when you actually try to create these feature modules, because those would be, the code for those would be only loaded when you load the right root path. So in this case, I clicked on watches, and then you can see that a second JavaScript file got loaded, which contains the functionality for that feature module, for that component that I'm loading. Okay, so in this case, you can reduce the size of the initial JavaScript bundle, which is main.js. Okay, and then last but not least, media asset optimization. So of course, you know, every website that you go to is going to have an image of some sort, right? It's just very difficult to find any website that doesn't have images or videos these days. I know that there's going to be a talk on largest contentful paint later on, so I'm not going to talk about that in depth, but let me also share this two tweets from this guy called Andrea Vatica. If you don't know him or you don't follow him, then please do. He does tweet a lot of interesting stuff about web performance. And so in these two tweets, and then the next one that I'm going to share with you, he's trying to highlight something that's very interesting. So he analyzed Beyonce.com, and then the other tweet, I think it was one of the Emmy Awards website that he analyzed, and he always found that the JavaScript for these two sites is relatively large. So in this case, it's 1 megabyte, and the other one is 2.5 megabytes. But the rest of the weight is always images. And it's often that when we think about these applications that we build, we are so much focused on the JavaScript bundle, how we optimize JavaScript, that we kind of forget about everything else. And JavaScript is not the heaviest resource on your page. It's always going to be the media assets. It's always going to be the images and the videos. And in this other tweet, you can see that 2.5 megabytes of JavaScript was served by this site, followed by about 23 megabytes worth of images. That's a lot. That's a lot more, and it can cause a lot more damage than the 2.5 megabytes of JavaScript, even though that is still a lot, depending on what you're trying to do. So in light of that, I'm going to show you this example, okay? So here we have the two images. One is manipulated with CSS, and the other one is manipulated by the Cloudinary Angular SDK. So these two images are kind of the same. And this is how the CSS looks like, okay? So I'm just applying it to the one and single image tag that I have. I set the width and the height of the image to be 200 by 200, and then I do object fit, object position, etc., etc., etc. What is wrong with this example? And it's not the code that's wrong, by the way. It's the concept that is wrong. Okay, so the code is perfectly fine, but it is the concept. So using the Cloudinary SDK, I do some optimization for that image. It is more complex, okay, I take that. But let's take a look at the end result. And what you see here is obviously a couple of optimizations, couple of transformations on the image, and then using the advanced image component, which is coming from a Cloudinary SDK, to display the image itself. But the main and most important difference is that when you look at these images in the network panel, one is going to be a 583 kilobyte JPEG, whereas the other one is going to be an 8.6 kilobyte AVIF. Okay, so you have reduced the size of the image considerably by using the appropriate image encoding, which is AVIF, and of course applying some other optimizations through the Cloudinary SDK. Now, if you think this is all made up, then come and see me. Thank you. Come and see me on the booth, and I'll run this for you. Okay, so I promise this is going to be fast because I know you're all hungry. So this is saying Bahut Shukriya, I hope so. So thank you for listening. Wait, not done yet. And if you have any questions, I'll be there until the end of the day. And now you can clap. Thank you.